Welcome to HopeTalk. In today's episode, we'll talk about islanding and anti-islanding protection. Have you ever wondered what happens when the grid power goes out, but your solar panels continue to generate electricity? This creates a situation where there is an uncontrolled island of power supply, which we call islanding. Islanding can cause safety hazards, equipment damage, and grid instability. To prevent islanding and ensure the safe operation of solar power systems, effective anti-islanding protection is essential. Anti-islanding protection involves detecting grid power outages and swiftly disconnecting the solar power system from the grid. There are two main types of detection methods, passive and active. Passive detection methods monitor changes in parameters such as frequency, voltage, and output power to probabilistically determine if islanding has occurred. While simple to implement, they can have blind spots when the inverter output power matches the load power. Active detection methods involve injecting small signals into the grid or inverter distribution point to detect grid faults. By observing changes in these signals, active methods can effectively identify islanding conditions and enhance detection accuracy. All Hopewind inverters are equipped with anti-islanding function. Let's take the HSNV 110 kilowatts inverter as an example. The HSNV 110 kilowatts inverter incorporates a combination of passive and active detection methods to ensure reliable anti-islanding protection. When islanding occurs, the Hopewind inverters detect grid voltage and frequency exceeding preset thresholds. Then the inverters disconnect from the grid and shut down to prevent further power supply. Simultaneously, they trigger alarms through our HopeCloud app. The islanding protection logic of Hopewind inverters is designed to swiftly respond to grid disturbances and ensure a safe disconnection from the grid within the required timeframe. And that's all for today's episode of HopeTalk. Remember, reliable anti-islanding measures are crucial for the safe and efficient operation of solar power systems.